The theme of this month's challenge is Bayes' theorem and conditional variance problems. So in both of these problems, our first step is we're going to be using Bayes' theorem, and then later on we'll be doing some sort of conditional variance calculation. Here, our spinner has two sides. One side comes up 1, 2, or 3. I'm going to note that side as side A. And the other is going to be 1, 3, 6, or 9. I'll let that side be denoted as B. A side is chosen at random, so probability of A is equal to probability of B is equal to 1/2 before we have any further information. And then we spin the spinner 3 times on that one side. So all 3 spins are either from A or all 3 are from B. X, Y, and Z are the outcomes of our spins. We are given that X plus Y is equal to 4. So the first thing I want to know is, well, what is the probability that side A was a side that was being spun 3 times, given that X plus Y is equal to 4? Well, this is just an application of Bayes' theorem. I'm just going to use first in the definition of conditional probability. The probability of A given this is the probability I have side A and X plus Y is equal to 4. And then I divide by the probability of what I'm conditioning on. The probability that X plus Y is equal to 4. My numerator, probability of having A and X plus Y being equal to 4, well, first I need to have A, which will have probability 1/2. And then I need X plus Y to be equal to 4, given that I was spinning side A. What about my denominator? The idea of Bayes' theorem as well. How can I figure out the chance that X plus Y equals 4? I'm just going to break it into 2 cases, namely a case of I chose A or I chose B. Now the case in which I chose A, that happened to be the exact same case we had in the numerator. It's just the probability of A times the probability of the sum being 4, given that we chose A. And then I'm going to add on to that the case in which I chose side B to spin. So I have the probability of B times a similar expression, the probability of X plus Y equals 4, given that we chose side B. Now what is this all going to equal? What's the chance I chose A? That's 1/2. What's the chance X plus Y equals 4, given that I chose A? Well, A means that I rolled a 1, I can spin a 1, 2, or a 3. So there are 3 ways that X plus Y could be equal to 4, given that I was spinning side A. I could have spun a 1 and a 3, I could have spun a 2 and a 2, or I could have spun a 3 and a 1. So there are 3 ways in which I could have spun it. Each of those ways had a probability of 1/3 of the first spin working, another factor of 1/3 of the second spin working. So I have 1/3 squared, or 1/9. And that's the same as the first case I have downstairs. And then what about our second case? There's a 1/2 chance I chose spinner B. If I chose spinner B, in order for the sum to be 4, I need to have spun either 1 as the first spin, 3 as the second spin, or 3 as the first spin, and 1 as the second spin. So that's going to be 2 times. Chance of 1 and then 3 is 1/4 for the 1, and then another 1/4 for the 3. Chance of 3 and then 1 is the same thing, so I get 1/4 squared. So now when all is said and done, and I reduce my fraction, I cancel out the 1/2, and I do a little bit of arithmetic, this reduces to 8/11. So that was a chance that I had came up with used spinner A, given the information that we have. Chance I used spinner B must be 1 minus that, must be 3/11. And so now I need to combine those pieces of information to get what I need. So how are we going to use the fact that the chance of being A is 8/11 and chance of B is 3/11? Well, we can make a little bit of a table with possible values of my third spin Z. Spinner A can be 1, 2, or 3. So those are some of my possible values. Spinner B can be 1, 3. 1 and 3 we've already listed. 6, or 9. And what else do I want to know? I want to know what's the chance that my third spin, capital Z, is equal to that specific value, conditioned on X plus Y, my sum of the first 2 being equal to 4, conditioned on the information that are already given. Well, some of these probabilities are easier to compute than others. What's the chance my spinner came up 2? I can only get a 2 on spinner A. There's an 8 out of 11 chance that I was using spinner A. There was a 1 in 3 chance that spinner A came up 2. How can I get a 1? I have my 8 out of 11 chance of using spinner A, 1 in 3 of it coming up 1. Then there's a 3 out of 11 chance of using spinner B, and a 1 in 4 chance of spinner B coming up 1. How can I get a 9? I can only get a 9 on spinner B. There's a 3/11 chance of using spinner B, a 1 in 4 chance of it coming up 9. And you get similar probabilities for being 3 or 6. And so now we just have a random variable that can take on 5 possible values, and I can just compute the variance the way I would compute the variance of any discrete random variable that can only take on 5 values. The fastest way to do that is to use the multi-view calculator. So if I use my multi-view calculator, I can go to the data menu by pushing the data button. And then in the first column, I'm just going to type in the possible values of my spinner A. Spinner A can be 1, 2, or 3. Then I'm just going to scroll to the right. What are the probabilities of taking on those values? Well, the chance of spinner A being a 1 is 8 over 11 times 1/3. 8 over 11 chance of spinner A, a 1 in 3 chance of coming up 1. So that's the probability of spinner A and then coming up 1. I have the same thing for coming up 2. Instead of retyping what I just typed, a little faster way to type it is just to say I want to do times 1. I want to do my previous thing, my previous value, times 1, because that's not going to change. It's just going to replicate what I had before. I can do times 1 again for a chance of spinner A being a 3. What about spinner B? It can be a 1, 3, 6, or 9. So now I have 1 actually in 2 different spots in my table. I have 1 in my first spot and my second spot because 1 is for spinner A and 1 is for spinner B. The calculator is smart enough to combine those later on when we're doing the stat analysis. And this just lets us have a little bit neater workspace. If you want, you could do the calculation in both things. I'm just doing it in what I find a slightly faster way of entering in all the numbers. The chance of having spinner B, that was 3/11. And then what's the chance of spinner B coming up 1? Well, I have to multiply that by 1/4, so times 0.25. So that gives me probability of spinner B being a 1. And again, I can just repeat my answer a few times for the rest of the possible values because everything in spinner B is equally likely. So now I have all my possible values in my first column, my L1 column. All of my probabilities are my second L2 column. And I can use a calculator to compute the variance and the distribution, anything I want about the distribution for me. So I'm going to say second quit. For a reason I'll explain in a minute, that's actually an important step. And then I'm going to say second stat to go to my stat menu. I want to do one variable statistics. My data, my possible values are in L1. The frequency, those are my probabilities. I put those in the L2 column. So I say I want to equal L2. And then I say calculate. It tells me n is 1. That's the sum of my frequencies, sum of my probabilities added up to 1. That's a good thing to check to make sure I typed everything in correctly. Then I scroll down to see what my sigma is. My sigma is my standard deviation. So I just copy my standard deviation. I want to know the variance. That's my standard deviation squared. So then I type in my square thing. The reason why I said it was important to do a second quit out of the data menu is because it got me back to this home screen. And so now when I just copied my standard deviation, I'll be back in the home screen. If I skip this step, it will try to plug this into my data menu where I was before, and that just makes things messy. It's something I want to avoid. So that's an important, useful step to have there. So anyways, I just want to square my standard deviation. And I see that my answer is that fraction, which isn't super helpful to me, so I convert it to a decimal, and I see it's 4.49. And so I compute that the variance of z, given that x plus y equals 4, is equal to 4.49. As an alternative approach, I could have used essentially double expectation, but I'm going to phrase it in terms of law of total expectation. I could have said, well, what's the expected value of z, given what we're conditioning on, given that x plus y is equal to 4? That there really are two cases. Either I was using spinner A, side A, or I was using side B. So the expected value of that is simply equal to the expected value of z, given that I was using side A, times the probability that I was using side A, given that the sum was equal to 4, plus the expected value of z, given that I was using side B, times, again, the same thing, the probability of having had side B, given that my sum was equal to 4. What's the expected value of z given I had side A? Well, there are three possibilities. Each are equally likely, namely 1, 2, or 3. So I just do the sum of my possibilities each times the probability of 1/3, which I factored outside. And the probability of having U side A was 8/11. The expected value of Z given I had side B, well, there are 4 possibilities all equally likely, namely 1, 3, 6, or 9. And the probability of side B was 3/11. When I evaluate that big mess, I get 2.75. So that's the expected value of Z given x plus y equals 4. I want the variance. What's the variance? It's the second moment minus the first moment squared. So let's find the second moment. So I can find the expected value of Z squared given that x plus y sums up to 4. What is that going to be? Well, I do the same sort of procedure, but instead of having the expected values here, I have the second moments there. And so I do this for my second moments. Again, I can factor out my common probability of 1/3 for each of the outcomes for spin A. The second moments I'll be doing 1 squared plus 2 squared plus 3 squared instead of 1 plus 2 plus 3. And I do a similar thing for the second spin side. And when I compute that, I get 12.05. So that my variance of Z, given that x plus y equals 4, is going to be 12.05 minus 2.75 squared, or my 4.49. As a side note, if we go back to our calculator display, it already computed for us that the expected value is 2.75. And if I scroll down for a while, the sum of my squares was 12.05. So it already found, I could have pulled these numbers immediately off the calculator as well.